Welcome to the void. It's cold, it's mostly empty, and statistically speaking, it's trying to kill you. But hey, welcome to space. A place where silence is deafening and time is just a suggestion. We are standing on a rock, orbiting a burning ball of gas, drifting through a cosmic shooting gallery that started with a bang 14 billion years ago. That was the birthday party, the fireworks, the confetti. But nobody ever talks about the cleanup. Nobody talks about how the party ends. Because it does end. The universe isn't a perpetual motion machine, it's a clock winding down. And right now, we are living in the brief golden flash of life before an eternity of absolute darkness. So, let's look at the chaos. Let's look at how the lights go out. To understand the end, you have to understand the war. And make no mistake, this is a war. A cosmic cage match between two titans that has been raging since the first second of existence. In the blue corner, we have matter. This is the stuff you know. It's galaxies, it's gas clouds, it's dark matter. It's the screen you're watching this on. Matter has one move and one move only. Gravity. Gravity is the obsession. It wants to pull everything together. It wants to hoard the universe into a tight, cozy ball. It's the cosmic equivalent of a hoarder refusing to let go of old newspapers. It pulls, it connects, it builds. But in the red corner is empty space. For a long time, we thought empty space was just nothing. We were wrong. Empty space is filled with a mysterious, invisible energy that acts like a repulsive force. We call it dark energy. And dark energy is the anti-gravity. It doesn't want to cuddle. It wants personal space. It pushes everything apart. It stretches the fabric of reality itself, driving galaxies away from each other faster and faster. So, here is the terrifying math. Matter is trying to pull the universe together, and dark energy is trying to rip it apart. The fate of every single atom in existence depends entirely on who wins this tug of war, and the winner depends on one specific variable. Does dark energy stay constant? Does it get stronger? Or does it get weaker? Let's look at the first, and frankly, the most likely scenario. The scenario where dark energy stays exactly as it is today. Constant, unyielding. If this happens, dark energy wins the war. It's not a knockout punch, it's a slow, agonizing suffocation. We call this the heat death, or the big freeze. And to understand what this looks like, imagine a cup of tea. The tea represents the universe. Now, drop a cube of sugar in it. That sugar is matter, galaxies, stars, planets. Right now, the tea is sweet. The matter is concentrated. But in this scenario, dark energy keeps pouring more and more tea into the cup, endlessly. The cup gets bigger and bigger and bigger. The sugar doesn't disappear, but it gets diluted. It gets spread so thin across such a massive volume of liquid that eventually you can't even taste it anymore. That is the future of our universe. Dilution. But here is the irony. While dark energy wins the universal war, gravity manages to win one final local battle. Because the expansion is happening everywhere, distant galaxies are pushed away from us faster than the speed of light. They cross the cosmic horizon and vanish from our view forever. But the galaxies right next to us, the local group, Andromeda, the Triangulum Galaxy, and the Milky Way. We are too close for dark energy to tear us apart just yet. Gravity locks us into a death spiral. Over the next few billion years, while the rest of the universe disappears into the dark, our local cluster smashes together. We merge. We combine into one gigantic, chaotic superball of trillions of stars. A monolithic super galaxy. And this will be our prison. If you were to stand on a planet in this super galaxy in 100 billion years, you would look up and see a sky full of stars, but if you looked past them, nothing. No other galaxies, no background glow, just an infinite, expanding, terrified dark void. We will be alone. And then the lights start to flicker. This super galaxy isn't immortal. It's a closed system. We stop making new stars because we run out of gas. The stellar nurseries shut down. The massive blue stars die first, exploding in supernova. Then, the yellow stars, like our sun, swell up and wither away. All that remains are the red dwarfs, burning their fuel with miserly slowness. But even they have to die. Fast forward trillions of years. The universe goes dark. The era of starlight is over. All that is left are the corpses, white dwarfs, neutron stars, and black holes. The cosmos becomes a graveyard of cooling cinders. It's a place of absolute pitch blackness, punctuated only by the occasional flicker of a dead star colliding with another. But wait, it gets worse. We enter the degenerate era. Over sextillions of years, even the dead stars cool down. White dwarfs fade into black dwarfs, balls of cold, crystallized carbon floating in the abyss. Planets are flung out of their orbits, drifting alone into the freezing void. Matter itself begins to decay. Protons, the building blocks of atoms, might eventually break down. If that happens, physical matter simply dissolves. And then we are left with the monsters. The black holes. They become the kings of a dead universe. But even kings die. Through a process called Hawking radiation, black holes slowly evaporate. They bleed energy into the vacuum. It takes a Google years. That's a 1 followed by 100 zeros. A number so big that if you wrote a 0 on every atom in the universe, you wouldn't have enough atoms. But eventually, the last black hole evaporates in a final silent pop. And that's it, the end state. A universe of pure entropy. No structure, no life, no light. Just a sea of photons cooled to absolute zero, stretching out forever. Perhaps just a single lonely particle traveling through an eternally expanding, featureless, freezing void, never bumping into anything, forever. It is the ultimate loneliness. A silence so profound it hurts to think about. A perfect, static, frozen tomb. Well, that was a bummer. That was depressing. But remember, that's only if dark energy stays constant. What if it doesn't? What if it gets stronger? What if, instead of freezing, reality is literally ripped to shreds? But if dark energy decides to go rogue and get stronger over time, we enter scenario 2. The Big Rip, a cosmic horror story that makes the heat death look like a relaxing spa day. Imagine the universe is a balloon being inflated, but instead of air, it's being filled with a terrifying substance called phantom energy. This stuff doesn't just push things apart, it accelerates exponentially, tearing at the very seams of reality like a rabid dog with a chew toy. At first, roughly 20 billion years from now, the effects are subtle, just a slight speed boost in the drift of the galaxies. The Milky Way has already merged with Andromeda to form Milkomeda, a massive island of stars, but suddenly the neighboring galaxy clusters we used to see in our telescopes start vanish faster than your paycheck on a Friday night. They aren't just moving away, space is expanding faster than light between us and them, creating an event horizon that swallows the rest of the universe. We are now truly alone, trapped on a galactic island in an infinite black ocean. But the phantom energy is hungry, and it's not done. About 60 million years before the end of time, the expansion becomes strong enough to overcome the gravity holding our own galaxy together. This is the Great Cosmic Divorce. Stars at the outer edges of Milkomeda are peeled away into the void, one by one, until the night sky goes completely black. There are no constellations, no nebulae, just the blinding, lonely light of our own sun, which is now drifting through nothingness, completely isolated from its stellar siblings. It's a level of isolation that would make a monk go insane. Then, 3 months before the end, the solar system itself comes under attack. The dark energy is now so dense that it overpowers the sun's gravitational grip on the planets. Earth is unmoored, flung out into the freezing dark, drifting away from the sun like a discarded soda can. Life on the surface freezes instantly, the atmosphere turns to snow, and the oceans become solid blocks of ice. But the violence is just getting started. In the final 30 minutes of existence, the expansion force hits the planetary scale. This isn't an earthquake, this is space itself expanding inside the Earth. The crust cracks open, magma spews into the vacuum, and the entire planet literally explodes, ripped apart from the inside out. Mountains, cities, and bunkers are reduced to rubble, floating in an expanding void. But we have to go smaller. In the last fraction of a second, specifically 10 to the power of minus 19 seconds before the end, dark energy becomes stronger than the electromagnetic force. This is where physics completely breaks down. Atoms themselves are torn apart. Electrons are ripped from their orbits and atomic nuclei are shredded. Matter as we know it ceases to exist. And then, the finale. In the final instant, space-time itself is ripped asunder. Even black holes, those monsters of gravity, are torn apart, exploding with the force of a trillion supernovae. The fabric of the universe shreds, leaving absolutely nothing. No space, no time, just a mathematical error where a universe used to be. Now, shake that off, take a breath, and let's pivot to scenario 3, the Big Crunch. This is the exact opposite nightmare. What if dark energy isn't constant or growing? What if it's unstable and eventually decays? If that happens, gravity, the patient underdog of the fundamental forces, finally wins the tug of war. The expansion of the universe slows down, stops, and then reverses. The cosmos hits the rewind button. At first, this seems almost poetic, like the universe is bringing everyone back together for a reunion. For billions of years, distant galaxies start rushing toward us. We see a blue shift in the sky, a signal that everything is inbound. When galaxies collide, it's usually not that violent. Stars are so far apart they pass right through each other like ghosts. But as the universe shrinks, the density goes up. The real terror here isn't the collisions, it's the temperature. Remember the cosmic microwave background radiation? That leftover heat from the Big Bang that's currently freezing cold? As space compresses, that radiation has nowhere to go. Its wavelength shortens, shifting from radio waves to microwaves, then infrared, then visible light. The entire vacuum of space begins to glow. The night sky turns from black to red, then orange, then a blinding, searing yellow. The universe becomes an oven, and there is no escape. Space itself becomes hotter than the surface of a star. Stars aren't just burning fuel from the inside anymore, they are being cooked from the outside in. They begin to boil and evaporate. Planets are vaporized instantly, stripped down to their cores and then dissolved into plasma. It is a claustrophobic hellscape where matter is crushed closer and closer together. Black holes begin to merge, devouring everything in a feeding frenzy until the entire universe is one supermassive black hole containing all mass and energy that ever existed. Finally, even that collapses. The entire cosmos, every timeline, every memory, every atom is crushed into a single point of infinite density and temperature, a singularity. Game over. Or is it? Many physicists love the idea of the Big Bounce. They theorize that this crunch could trigger a new Big Bang, spitting out a brand new baby universe with new laws of physics, rising like a phoenix from the ashes of our destruction. It's a beautiful, terrifying cycle of death and rebirth that might have happened infinite times before. So, where does that leave us? Honestly, most evidence still points to the first scenario we discussed, heat death. And while fading away into a cold, dark nothingness sounds depressing, it's actually the best news you could possibly hear. Why? Because it's slow. We're talking googles of years. It means the universe isn't going to rip us to shreds next Tuesday or crush us into a singularity before lunch. It means we have an unimaginable amount of time to master space travel, to jump between galaxies, to harvest energy from black holes, and to see everything this reality has to offer. We have been gifted the golden age of the cosmos. The stars are bright, the planets are forming, and the universe is practically begging us to explore it. So don't let the existential dread win. You are the universe experiencing itself, and you have front row seats to the greatest show in existence. Do not waste it doom scrolling. Use that time to learn, to create, and to understand the bizarre reality we live in. And the best way to start? By smashing that subscribe button so you don't miss the next crisis, hitting the like button to fight the algorithm's entropy, and clicking right here to find out what happens when you fall into a black hole. Because if you think the Big Rip was crazy, wait until you see what gravity does to the human body.